Hi, I'm Elizabeth, and today we're going to be going over the combined gas law. So the combined gas law is P1V1 over T1 is equal to P2V2 over T2. In your book, it could also say final pressure times final volume over final temperature is equal to initial pressure times initial volume over initial temperature. So just keep in mind that there's multiple ways to say this, and they're both correct. So just make sure that the conditions stay together. As we previously discussed with our previous gas laws, we know that pressure and volume are going to be inversely proportional. So let's write that out. So pressure and volume are inversely proportional. Volume and temperature are directly proportional. And we're also going to see that pressure and temperature are also going to be directly proportional. So what do all these words really mean? What is inversely proportional? What's directly proportional? So inversely proportional just means that if one is going up, the other one is going down. If the one is going down, then the other one's going up. So if I am increasing pressure, I'm going to be decreasing volume. If I'm increasing volume, I'm going to be decreasing pressure, etc., etc. Directly proportional means that if one goes up, so does the other, and if one goes down, the other one goes as well. So if I decrease pressure, I decrease temperature. If I decrease volume, I decrease temperature as well. So an easy way to see that is if they're being multiplied together, they're going to be inversely proportional. If they're being divided by each other, then they're going to be directly proportional. That's one way to see it very quickly, and those are very common questions asked. So let's see how we can actually apply this, right? So I wrote out an example over here. It says a sample of nitrogen gas at 18 degrees Celsius and 760 millimeter mercury has a volume of 3.92 milliliters. What is the volume at 0 degrees Celsius and 1 atmosphere of pressure? So another thing we need to talk about is our units. So our units for pressure need to be in atmospheres. Our units for volume need to be in liters, and our units for temperature need to be in Kelvin. So let's go ahead and kind of circle or underline what's given to us, right? So I have a temperature here. This would be T1. Here I have a pressure. This would be P1. And I have a volume, which would be V1. And I know those are all ones because they're found all together. So the gas is at 18 degrees Celsius and 760 millimeter mercury, and that's the volume for it. And then they're asking for the volume, so that's going to be V2. They give you 1 atmosphere, which is P2, and then they give you 0 degrees Celsius, which is going to be T2. Almost wrote P there, but that's a T, I promise. Okay, so let's see. First, we have to convert our temperatures into Kelvin. So I'm going to go ahead and write that like right here. So T1 is equal to 18 degrees Celsius. We add 273.15, and that's going to give us our Kelvin. So 273.15 plus 18 is going to give me 291.15. So that's going to be my new T1. For my P1, they gave me 760 millimeter mercury, and I have to convert that to atmospheres. So I know that there is 760 millimeter mercury in 1 atmosphere. 1 atmosphere. Ignore the M there. So as you can see, 760 divided by 760 is just 1, so that's 1 atmosphere. All right, and then we have also volume in milliliters. So V1, 3.92 milliliters, but I need that in liters. So there's 1,000 milliliters in 1 liter. So that's going to give me 0.00392 liters. So these are my new values that I'm going to be plugging in. And we need to convert T2 as well, because that's given to us in 0 degrees Celsius. So plus 273.15, that's just going to give me 273.15 Kelvin. And it's 1 atmosphere. It's already an atmosphere, so it's all good. All right, so now we just plug in and solve. If you would like, you could solve for V2 conceptually, so without having to plug in numbers. I personally like plugging in numbers and just solving for like the X value. So I'm going to do it that way, but feel free to solve for it whatever way you see fit. All right. So my pressure 1 is going to be now 1 atmosphere, right? Because we have that right here. So 1 atmosphere. My first volume is 0.00392 all over my first temperature, which is 291.15 Kelvin, and this is liters. Is going to be equal to my second pressure, which is also 1 atmosphere. I'm solving for V2, and my second temperature was 273.15. So let's make a prediction real quick, right? My pressure stayed basically the same, so that's not going to really affect my volume, but my temperature went down. So we know that since volume and temperature are directly proportional, that my volume should be lower than 3.92 milliliters. So let's see if that's true. So I'm going to have 0.00392 divided by 291.15 on the left side. So that gives me a very small value. It gives me 1.35 times 10 to the negative 5th. And then I have 1 atmosphere V2 over 273.15. So to get rid of that denominator, I can multiply 273.15 on both sides. And that'll cancel that. So now I have 0.00368 liters is equal to V2, because 1 is just 1. So that's 3.68 milliliters, which is smaller than 3.92. It makes sense, so that means our directly proportional thing is still working here. So to recap, your combined gas law is P1V1 over T1 is equal to P2V2 over T2. Make sure that your units are correct, so your pressure has to be in atmospheres, your volume has to be in liters, and your temperature has to be in Kelvin. And remember these properties, make your prediction before you do your calculation to make sure that you're going along in the right direction. We hypothesized that the volume would go down, and indeed it did because the temperature went down, and they're directly proportional. Also, make sure to correctly identify what stays with what and what goes with what. So make sure that your initial values and your final values stay together. You don't want to be mixing those up, because then that could give you the wrong value for your answer. And that's how you use the combined gas law.